When looking at paired data, essentially what we're going to do is we're going to use the formulas that were associated with estimating a single mean, right? Because we have one column of data, the differences. Therefore, we're going to analyze our data as one column. However, our inferences that we gather from our statistical analysis will be based on the difference between two means. So we're going to use the formulas associated with a single mean, but the interpretations and the inferences associated with the difference between two means. Every formula that you see here, you have already learned. D bar is essentially X bar, right? But the D just stands for the differences. S sub D, that's just your standard deviation, which we denoted as S. It's your standard deviation of your differences. So we're just throwing in D's in places to represent, these aren't typical observations. They're observations comprised of the difference between the pair. Our confidence interval, it's the exact same as estimating a single mean, right? But again, you'll just notice D's to represent differences. Same thing with hypothesis tests, same exact formula. So we should be comfortable performing hypothesis tests for paired data. Since we've already learned these formulas, we're doing the same exact formulas as a single mean, except our inferences are going to be on the difference between two means. Our hypotheses are in terms of the single mean mu d, and we're primarily going to be interested in if that population mean equals 0. Because if that population mean equals 0, what that represents is mu1 minus mu2 equals 0, which implies mu1 equals mu2 to the same value. So we can see how we're combining the two different things we've learned, a single mean formulas and the difference between two means hypotheses essentially. So we can see how we're combining single mean formulas with inferences based on the difference between two means.